Hello class, welcome to this video on the Chapter 10 test practice. So we're going to cover the questions on one of the versions of the test on the unit on circles. Let's go ahead and get started. So it says, assume that lines appear to be tangent are tangent. O is the center of the circle. Find the value of x. And assume that figures are not really drawn to scale. So here we got what appears to be a tangent line here. And we know that a tangent line paired with a radius form a perpendicular pair. So I know that if I have a tangent line to a circle, which crosses a circle at one point, and in the radius of a circle, I know that they form a 90-degree angle. So that's one of the theorems, and we know that this is a right triangle because of that. So because it's a right triangle, if I know that this angle here is 14 degrees, then I can figure out what x is by the triangle angle sum theorem. So I know that 14 plus the 90 plus the x has to equal to 180 for a triangle. And then I proceed to solve for x here. So let's combine the like terms. Get 104, subtract 104, and so x has to be 76 degrees. All right, for the second question, name the major arc and find its measure. All right, so we know we have angle ACB. Now this angle right here is a central angle, and the central angle is always equal to its arc, okay, or the arc is always equal to, the measure of the arc is equal to the measure of its central angle. So this is also going to be 50 degrees. Now this is a minor arc since it's smaller than a half circle, so it's less than 180. And so the major arc is the rest of this part here. And we know that a full circle is 360, so this is 360 minus 50, which is 310. So the major arc is ADB, or BDA, and it's 310 degrees. All right, so JK, KL, and LJ are all tangent to circle O. JA is 9, AL is 10, and CK is 14. Find the perimeter of triangle JKL. Well, we know that if we have the segments to a tangent theorem is that if you have two tangents, right, that meet at a common point, then those two tangents are actually congruent. The length is the same. So those are congruent, these are congruent, and these are congruent. Okay, so if that's 9, this is 9. If that's 14, that's 14, and so on. Then we can proceed to add up all these sides. That's 19, that's 23, and that's 24. We can find the perimeter by adding up those three sides. So we have here, that's 47, so it's 19 plus 47, which is, it's going to be 66 for the perimeter. All right, so for the next one, find the length of YPX. So we want the actual length, not the measure, the length, YPX, so we want that. Now, in order to find that, we need to first find this. Well, we need to use we need to know the central angle. Okay, so the central angle for this is 90 degrees, right? Which means that the central angle for this black arc is 360 minus 90, which is 270. So this is going to help us. 270 is what we need. So we need 270. We know that the radius is 10. So remember that the arc length is given by the angle, the central angle, divided by 360. So what fraction of the circle I'm covering, and I'm covering 3/4 of the circle because 270 is 3/4 of 360, and then times the circumference to get the length. So the circumference of a circle is 2 pi r, so it's going to be 2 pi times 10 because the radius is 10. So I get, this is 3/4 of 20 pi. So 20 divided by 4 is 5, and then 5 times 3 is 15. So the entire circle would be 20 pi. This part would be 5 pi, and this part is 15 pi. And that's the part that we want, the 15 pi part. So it's 15 pi meters. So find the area of a sector with a central angle of 170 and a diameter of 9.1 centimeters, round to the nearest tenth. So we got a central angle, so we can easily find the area of the sector. Now the area, remember, is not the same as the arc length, so you want the actual area. So the area of any given sector So if I wanted to get the area of that sector, I need the radius, and I need this angle. The angle here, theta. Okay, so the area is a fraction of the entire circle, which is pi r squared for the entire circle, and then a fraction of that. So it's going to be theta over 360. All right, so the area for here is going to be the fraction of the circle, which is 170 for the angle over 360, times pi r squared. Now the diameter is 9.1, which means that the radius is always half of the diameter. So I could do 9.1 divided by 2. So this is 9.1 divided by 2 squared. Okay, so that's the radius squared right there. And then we can plug this in and get a decimal out of it. Let's see here. So we got 170 over 360 times, then we got pi times 9.1 divided by 2 squared. And we could do this in chunks. So this part is equal to that. And then I can do, okay, so then I could do that times all of this and see what we got here. So 30.71, so about 30.7 centimeters squared. All right, the instructions explain how to construct an equilateral triangle inscribed in a given circle, which is most likely the missing line from the instructions. So mark point A on the circle. Step 2 is blank. Step 3, place the compass point at A and draw an arc. Move the compass point to the intersection of arc and circle and draw another arc. Repeat until you have 5 arcs. Draw chords between the first, third, and fifth intersections. So that's exactly what it's saying. So if you wanted to make an equilateral triangle, you need to, well, you need to measure this arc here, or this radius, sorry, with the, so pick a point on the circle. Let's say I pick that, measure that radius, and then use that, mark out that radius on the circle, and then go from there and mark until you get 5, arcs in total. So 1, 2, 3, 4, and then another arc. And once you mark out those, then you connect every other arc to make your triangle. So the step 2 that it's missing, mark point A on the circle, we got that. Let's call this point A. Then the part that's missing is you need your compass to measure that radius. So let's just assume that that's your compass. You need to measure that radius out. So set the compass to the radius of the circle. All right. Number 5, find the value of x for the measure of arc AB is equal to 46, and measure of arc CD is 25. All right, so we got arc AB is 46 degrees, arc CD is 25. The figure is not drawn to scale. Okay, so find x. So there's a theorem that states that if you have 2 intersecting chords or 2 intersecting secant segments on the inside, then you can find each of those angles by taking the average of its arcs. So the average of the 2 arcs. So to find x, I need to take the average of the 2 arcs here. So 25 plus 46, then divide that by 2. So we add these together, we get half of, this is going to be 71. So half of 71 is 35.5. So each of these is 35.5 degrees. All right, find the circumference. Leave your answer in terms of pi. So the circumference of a circle is 2 pi times the radius. We got the radius is 18, so it's 2 pi times 18, or 36 pi. Pretty straightforward. All right, find CA. So if you have two intersecting segments on the outside of a circle, then the angle between those 2 segments is given by half the difference. Or it's given by, well, the angle is given by half the difference between the 2 arcs. However, the length of the segment itself, if you to find the lengths of each of these segments, the product is constant. So that means the product of this red and this purple is the same as the product of this red and this purple. So it's usually outer times the entire length, and outer times the entire length. Now for CD, the outer is the entire length, so it's still going to be 45 times another 45. Now for this secant segment, it's the outer, which is 27, times the whole thing, which is 47x plus 1 plus 27. So this purple part is 47x plus 1 plus 27. All right, so you take the product and set them equal to each other. So we got 27 times 47x plus 1 plus 27, the entire thing, is equal to the product of the 45 times the whole thing, which is another 45. And there's your equation, and that's for intersecting segments of a circle on the outside. So we distribute this, of course, we combine like terms. So let's combine this, and then we'll distribute. So we got 27 times 47x plus 28. Then we got 45 squared, which we can do here. So it's 2025. Then we can distribute this. So we got 27 times 47, 1269x plus, and then we got 27 times 28, which is 756. And then we solve for x. So we subtract 756 on both sides. If I'm not mistaken, we should get 1269 out of this. But I'd like to double check. Yep, we get the same thing, 1269. So divide by 1269 on both sides. So x has to be equal to 1. All right, so we got x is 1, and then we want to find CA. So we want to plug it into that whole thing, which is the purple. So we're going to plug it into the purple part right here, which is the 47x plus 1 plus 27. So CA is 47 times x plus 1 plus 27. And yeah, like that. There you go. And we already know that that was 28, so I'm just going to do plus 28. So we got 47 plus 28, which is 75. All right, so that's how you solve those types of problems. Now the next one, AB is tangent to circle O if AO is 24 and BC is 50. So this BC here is 50. What is AB? So let's call that X. The diagram's not to scale, so we know that this is a radius. So if that's 24, then this is 24, which means that this whole thing is actually 74. And so we know that a tangent line, which is AB, and this radius always meet at a 90-degree angle. And so we know that this is a right triangle. We can use Pythagorean Theorem here. A squared plus b squared equals c squared. So we got x squared plus 24 squared equals 74 squared. And then we can solve for x. So we got x squared equals 74 squared minus 24 squared. I'm just subtracting this over and moving it over to the other side. And then I could take the square root of that. So we take the square root of 74 squared minus 24 squared, and we get 70. All right, find the area of the circle, leave your answer in terms of pi. Now we know the area of a circle is pi times radius squared, so we can just plug in what we know. We know that the diameter is 4.1, which means that the radius has to be half of that. Okay, so we have 4.1 divided by 2 squared. We want it in terms of pi, of course, so we're going to do 4.1 divided by 2 squared, and that's 4.2025. And so this is going to be 4.2025, and then just stick the pi after it, and then you got your area in terms of pi. All right, so next question, find the value of x. If necessary, round to the nearest tenth. O is the center of the circle. All right, figure is not drawn to scale. So we want to find x here, this angle. Now, if we want to find that angle, well, we know that that angle is equal to, well, we know that its arc is equal to that. And it says that this arc is equal to this arc. And that arc is 77. And therefore, this arc is 77. And therefore, x has to be 77. Not a trick question. It's just being able to understand congruent measures and congruent arcs. And there you go, 77. Pretty straightforward. All right, so next question, in circle Z, BZ is congruent to FZ. So these are congruent. BZ is perpendicular to CA. So this is perpendicular there. And FZ is perpendicular to DZ right here, DC. And DF is 18 inches. So this is 18 inches from D to F. And what is BC? So what is that? So there's a theorem that states that if you have something that if you have a radius or something like that, if I can take this and I can make it into a radius, right? And this radius here, if this radius cuts a chord in a 90-degree angle, which we know it does because they mentioned that, then that means it cuts the chord in half. And so if that's 18, this is 18 inches. There's also another theorem that states that if the distance from the center to two chords is the same, then that means that the two chords must be the same length. And so these are cut in half, but the theorem states that this is also congruent to this chord. And so these have to be the same length, 18 inches. So that means BC is actually 18 inches. And let me reiterate that again. If you have two chords, any two chords, and the distance between those is the same, then that means the chords must be the same length. Okay, so these two are the same length because the distance from the center is the same. So this is really two theorems in one. All right. Okay, so we know that this is 18. So for the next question, we got EF. Find EF. And again, this is similar to one of the other questions where we had two secants or two segments on the outside that intersect on the outside, and you're trying to find the length. So you take the outer segment times the whole, outer times whole, and outer times whole, okay? And take the product. So we got the outer times the whole. Now the whole is 11 plus 9 equals the outer, which is 4 plus x, times the whole, which is 4 plus x plus 2. All right, so we got 9 times, this is just 9 times 20 here. Here, let me just use another color. We get 9 times 20 equals, so this is going to be 2x, and this is going to be 6. So this is going to be 4 plus x times 6 plus 2x. All right, so we got to FOIL this. This is going to be 180, 9 times 20. Now for this, you got to FOIL, so you got to distribute from there and there. So 4 times 6 is 24. 4 times 2x is 8x. Then you got to distribute this to the other side. X times 6 is 6x, and x times 2x is 2x squared. Okay, so we got 180 is equal to, combine your like terms, 24 plus 14x plus 2x squared. Okay, so this is a quadratic equation because we had this with the squared there. So we want to make sure that everything is equal to 0 on one side. So I'm going to move this over to this side because I want 0 to be on one side. So, and also I want to reorder this. You want this to look nice with the x squared first, and then the x, and then the constant. So let me rearrange that first. So we got 2x squared plus 14x plus 24. All right, now let's subtract the 180 and make that 0. Every time you have a quadratic, you want to make one side equal to 0, like that. And so we got 180 minus 24, or 24 minus 180 is going to be negative 156. And then we don't like that 2 there, so I'm going to divide everything by 2. So we get 0 equals x squared plus 7x minus, and then we got 156 divided by 2. It's going to be 78, if I did that correctly. Yeah, it sounds about right. And then now you need to factor this or use quadratic formula, something like that. Now we're going to try factoring this. See, so we need two numbers that multiply to negative 78 but add up to 7, positive 7. So let's see if we can find two numbers that multiply to negative 78. So 78 divided by 2, 2 and 39, that doesn't make 7. So 6 and 13 could make 7. So we got 6 and 13 if one of them were to be negative. So if 6 were to be negative, 13 plus negative 6 is 7. And then 13 times negative 6 is negative 78. So there you go, we got it. So we got 0 equals, then you factor this. So write it as basically like a FOIL again. And you got minus 6 and then plus 13. So now if you FOILed this, you would get the original, which is the purpose of why we did all this. So now we got to figure out what makes this equal to 0 and what makes this equal to 0. So this would have to be 6. 6 minus 6 is 0. And this would have to be negative 13. Negative 13 plus 13 is 0. So we got two solutions. Only one of these makes sense, though. It doesn't make sense to have a negative solution. So we're going to have x equal to positive 6. Now, it doesn't make sense to have negative because, you have lengths here, and you can't really have a negative length. So that wouldn't make sense here. So x have to be 6. Now, they're not asking for x here. They're finding EF. So we're going to plug into EF. Now, we know EF is 4 plus x. So we got 4 plus, and then x is 6. So we got 4 plus 6, which is 10. And there's our final result. So that one was a little tough because of the quadratic and so on. All right, the next one, CDA is equal to 11. So let's label that. Angle CDA, so this is 11 degrees. What is the measure of CBA? CBA, so we're looking for that. All right, well, we're going to use inscribed angles to help us out here. We know that an inscribed angle is an angle with two chords. So AD is a chord, DC is a chord, and the vertex is on the circle, which is at point D. So this is an inscribed angle. We also know that by the inscribed angles theorem, if you have an inscribed angle, it's always going to be half of its intercepted arc. So that 11 is half of this arc here. And so that means this arc has to be 22 because that half of 22 is 11. And so there you go. That's our arc. Now we also know that this is also an inscribed angle, angle CBA, which is what we're looking for. And notice that it inscribes the same arc. It's the intercepted arc for that is the same, which means that if the intercepted arc is 22, that means this has to be half of 22. So it's going to be 22 divided by 2, which is also 11. And there you go. So both angles are actually 11 in this case. All right, so measure of arc DE is 120. So DE, this arc here is 120. BC is 53 degrees. Find the measure of angle A. So, as we mentioned at one point in one of the earlier questions, I have two intersecting segments on the outside. And to find the angle, I need to take half the difference of those two arcs. So I need to take the difference between these two, that one and this one, the two intercepted arcs, and divide by 2. All right, so the measure of angle A is half the difference. If it intersects on the inside, it's the sum. If it intersects on the outside, it's actually the difference of the two arcs. So you have 120 minus 53. So it's going to be half of, and then we got to do 120 minus 53, which is 67. And then half of 67 is 35.5. Oops, 33.5, not 35.5. There you go. There's my answer. For the next one, find the measure of BAC in circle O. BAC. So we want to figure out this angle. Now we do know that this is 85, and let's see here. So yeah, so they give us that this is 85. So that's that, which means, and that tells us that if that's 85, that means and that's a central angle, and that means this is also 85. And we know that this is a diameter, this right here is a diameter, which means it cuts the circle in half, which means that this entire arc is actually 180, because that's a half circle. Now, if that's 180, then that means that this part right here is 180 minus 85, which is 95. So we know that that red arc is 95. And if that's 95, well, notice that this here is an inscribed angle, which means that an inscribed angle is always half of its arc. So this is going to be half of 95, which is 47.5. All right, so AC is tangent to circle O. So this is a tangent. If the arc BY is 24, so this is 24, what is the measure of angle YAC? So they want this angle here. So if they want that angle, well, we know that a theorem that states that if you have a chord and a tangent, the angle between the chord and the tangent actually behaves like an inscribed angle. Even though this is not an inscribed angle, it behaves like such that the intercepted arc is always going to be, or the angle is always going to be half of the intercepted arc. So we need to find this intercepted arc first. But we do know that this is a diameter, which means that this whole thing adds up to 180, which means that this red arc is 180 minus 24. And so this is going to be 156. So there you go. There's my angle, 156. And so we can take half of that to get this black angle here. So it's going to be half of 156, which is 78. All right, find the measure of the indicated angle. So again, we have an angle on the outside by intersecting segments. And we know that the angle here is half the difference between the bigger intercepted arc and the smaller intercepted arc. And we can get the smaller intercepted arc because notice that these two arcs add up to a full circle, or 360. So that means that this has to be the difference between the full circle and the 200, which is 160. So now we know that this is 160 degrees. And we can proceed to take half the difference between those two to get this angle. So this angle is half the difference between the purple and the red. So it's half of 40, which is 20. All right, find the value of x. If necessary, round your answer to the nearest tenth. So we have intersecting chords or secant segments. Now, if you have intersecting chords like this, we said that the angle is half the sum of the arcs, right? Now, this time we're not dealing with the angles, we're dealing with the distance. It turns out that the distance, the product of the distances of each part of the segment, is equal to the product of the other part of the segment. So those two black ones multiplied is equal to these two red ones multiplied. So it's 9 times x is equal to 6 times 16. So we got 9x equals 96, and we could divide by 9 on both sides. This should be, yeah, that's 96. And we get to 96 divided by 9, which is not going to be a nice number. It's going to be more than 10. So my guess is going to be the answer with 10. So it's going to be about 10.7. All right, and that's the value of x. All right, that's going to do it for the video, guys. I hope you found this useful. I hope you learned a few things and took this as a good review. As usual, I'll see you in the next one.